first thing you notice, well, even yesterday, everybody's like, first thing, fraction, everybody panics. But it's just a rational function. So address, God bless you, address your denominator. What can you not have in the denominator is a 0. So set whatever is in the denominator equal to 0. And remove that from your domain. Your range is going to wait till later. You can do your domain first. Okay? Then second, I would go, well, factor, if we can't factor anything, I would go to your asymptotes. Follow your rules for your asymptotes. Okay, your vertical asymptote is the same as what's left, well, not the same, because we're going to factor it, but it's what's left, in this case, from your denominator. And your horizontal one gives you 3 choices. Can everybody do those 3 choices? With the degree, comparing the degree in the numerator to the degree in the denominator? When they're the same, take the coefficients and set them equal to y. Make the ratio of your coefficients. That's your line. That's your horizontal line. That's this guy right here. Okay, so we've got an x equals 0, which is along your y-axis, and a y equals -1. That's your guidelines also when you go to sketch your graph. So you can see how your curve fits right in here. Excuse me. It's much easier to do it after your asymptotes are on your paper. Yes.
What's the word for vertical?
Denominator. That's my denominator. If you look in the denominator, that's where you get your zeros of your denominator. These are your zeros from your denominator. But it's after you factor, but we had nothing to factor.
So what's the one right next to horizontal?
Degree in the numerator equal degree in the denominator. That's on your sheet. That's on your sheet. Again, this had no min, no max. It has a concavity, concave up, concave down. And both of these intervals are decreasing. Your y is decreasing as you read x left to right. And your intercepts. Zeros of your numerator are your x-intercepts, and your y-intercept, plug 0 in, and you'll see it's undefined. And that's why you don't see anything touch the y-axis, because you have an asymptote. Remember, you can never cross a vertical asymptote, because that's a restriction of your domain. That's from your denominator. So you can never cross a vertical asymptote. You can, however, cross a horizontal asymptote. Even if you cross it, the behavior still works along that asymptote. Stop me if you have any questions. Alright, this one's a little tricky because of that negative sign out there. You're going to have to do something with that negative sign. It's either going to have to go into the numerator or have to go into the denominator. Because if you just look at your zeros of your numerator, you look at your zeros of your denominator, you ignored your negative sign. So that has to be somewhere. So I moved it to my numerator. And remember, when you put it in your numerator, it's not this, it's this. You're moving it up to your numerator. A negative sign can sit in the front of a fraction, in the numerator, or in the denominator. But when your numerator and your denominator have more than one term, you have to share that negative. Did you guys get that part? Or did you got it? You might have seen it once you graphed it. Once you graph it, you might have seen that something went wrong. So look at your denominator restriction. Do that first. There's nothing else for us to factor. Do your asymptotes. Work your intercepts. Once you get your asymptotes, and if you didn't, and your x was positive 2, so your x would have been negative 2. Oops, it would have been negative, then you would have just worried about which way you were facing. And that probably would work out for you. Because you're going to just graph it off your calculator anyway, not off the graph. Okay, then your intercepts. Again, no min, no max. Today we're going to see mins and maxes because we're going to do slants. No inflection points. They're both, again, decreasing intervals. Questions?
How do you do
The range. The range, you go back after you do all your asymptotes and you're finished. When today we're going to do something else with it too. Probably 3/4 of the way through, after you get everything on your graph, then go to your range. Your range is your y. So my advice is go like this. Come from down here, come from negative infinity. See your negative infinity? Come from negative infinity. Whoops, it stopped right there. What is this y value right here? Negative what? I'm sorry. Negative 1/2? Nope, negative 1. This is your negative 1 right there. So jump over your negative 1, and then it goes continued again. Just follow it, follow your graph. It's coming from negative infinity. It's jumping over this point because it can't use negative 1. There's your asymptote right here. There's your asymptote. Your negative 1/2 is an intercept. Was right here. That's where your intercept was for your y-axis. But follow your graph. It's going from negative infinity. It's got to jump over this and then continue. And I don't have the range. Oh, the range was up there. Okay. Good morning. Sorry, next to the lake book. Okay, the range was right up here. See it? Just take it out. Take the negative 1 out of your allowable domain range. Okay, this one was similar, I think, to the one we did in class. No, not really. Again, you have a domain restriction. You can't use a 0. Nothing to factor. You can find your asymptotes. Use your rule. Can everybody follow the rule with the degree in the numerator, degree in the denominator? Okay. There's no other way around that one. When we do limits, we do the same type of comparison. So it's kind of nice to get that down pat because we'll do that again. No min, no max. Now this time you have an increasing and you have a decreasing. Here's your increasing segment. Y is increasing. Here's your decreasing segment. You had no y-intercept, and so when you look at this, you should realize that when you solve it algebraically, it shouldn't have had an intercept. Same thing with the x. There's nothing in the numerator. There's no zeros in your numerator in this. And if you just plugged in the 0 for the whole thing, you would see. You cross multiply, there's no intercepts. And they're both concaving up. Yes? Yes, because they make an upward movement each time. They make the upward. They concave up. Well, the concavities, yeah, we read them left to right, but our movement is concave. They make an upward, like if I was to go, like, continue this like this, they make a concave up. That pretends you just drag the sides up. Versus when they come here, a concave down. Okay. This one had a double factor, well, triple factor, but we're still looking at one domain restriction in the denominator. Your y-intercept, your x-intercept, no zeros in the numerator. Just by looking at your fraction, you have no x value in your numerator. So you're probably not going to have an x-intercept. So just plug the 0 in and you cross multiply and you have no intercept. No inflection, you have concavity. They're both decreasing. Once you get your asymptotes, plug it into your calculator, you'll get your sketch. And you can confirm your intercepts on your calculator. Go to go to your table. You'll see the 0 for x. You'll find the y-intercept. Okay, you'll see at the 2, it says error. Confirm these on your calculator. Because today, we're going to add a little bit of another one in here. The point of discontinuity. So they're kind of competitive. You get the hang of one, you should be able to do all of them. We can factor this, but nothing can be reduced. This is kind of looks like the one we did yesterday. This is like the one we did yesterday with the middle part. and then the two side pieces. So find your asymptotes. You probably had a little bit more work to this one. You had two values that you could not use in your domain, so you took them out of your domain. Your range, this right here, there's your range. See your range, all real numbers? If I come from the bottom, nothing stopped me. Even though this y was an asymptote, y equals 1, I can jump over this asymptote. A horizontal you can cross through, a vertical, never. That's a domain restriction. Your intercepts, there's your zeros of your numerator. This actually is an inflection. I said don't worry about the inflection point. This actually is an inflection. You came down, you should have gone up. Instead, you turned back this way, and this was a down. But I said don't worry about the inflection. I wanted you to see the rest of these instead. So you kind of have a partial concavity there. But today we'll add that in. Good? Let me hand out today's. Today's, it's just stay with me here. So the first thing we're going to do is find any domain restrictions. I always like to go for the domain restrictions. Actually, let's factor. Let's make that be number 2. Number 1, let's factor. And leave the factors here. Can I factor the numerator? To what? If it was a minus. Yeah, if it was a -4, I could. But this one I can't. So we couldn't factor this, so we're going to leave it big. So let's look at our domain restrictions. The denominator cannot be 0. So when x is 2, we have a problem. So we're going to take the 2 out of your domain. Okay. Now, from here, we have nothing to factor. We're going to go to your asymptotes. I didn't even graph it yet because I want to set my asymptotes up, get that all done, then put it in my calc, and then get my sketch out there. I think it's harder to sketch without the little pieces here first. Now, your vertical asymptote, these are the zeros of your denominator. After factoring. After factoring. But we cannot factor this, God bless you. So, we know that this now is the same as your domain restriction. So we have one vertical asymptote. Your horizontal asymptote says, look at the degree in the numerator, the highest degree. Look at the highest degree in the denominator. If the degree in the numerator is greater than the degree in the denominator, then what? None. You have no horizontal asymptote. Now, go a little bit further into your list to where it says slant asymptote. Go to your slant asymptote. What does your slant asymptote say? It's exactly when the numerator is exactly 1 more than the denominator. So is the numerator 1 more than the denominator? We now have a slant asymptote. And actually, I lied, Rich. We're going to synthetically divide here. Now, for your slant asymptote, let me do this up here so everybody can see it. A slant asymptote is just that. It's a slanted line. And your line format is still y equals mx plus b. For us to get this slant asymptote, we're going to just divide synthetically into this, divide this out. So, but we don't care about the remainder this time, so that's the nice part. We're going to pull out your coefficients. We're going to pull out your 0. When x minus 2 is a factor, then 2 is your 0. And we're going to synthetically divide. 1 times 2, 2. This becomes 0. This becomes 0. There's my remainder. My remainder, I don't care about. Now, if I had 2x, x2 on the top, x1 on the bottom, what's my result going to start with? X. And it makes sense, doesn't it? And you just do this. Y equals x. There's nothing to add here. Plus 0 is the same as y equals x. That has to have x to the 1 because it's a line. It's linear. So that exponent has to be a 1 when you do this. That's why the rule is the numerator is 1 more than the denominator. So the result will always be x to the 1. That's your format of a line. Right? That's your format of a line. Now, there's my slant asymptote. So let's start by graphing this. Let's put your asymptotes in. You had x equals 2. That was a vertical. And you had the line y equals x. The line y equals x cuts right through these quadrants. And isn't that a slanted line? That's your slant asymptote. Now, put it in your calculator, and we're going to graph it. So that slant asymptote is going to help you guide your end behaviors. Okay, so you should see something that looks like this. See it guide your end behaviors? You see now you have a minimum, and it's going like this, somewhere over here. And now you have a maximum. See it? You have concavity. Everything else is going to be exactly the same. Okay. So a min and a max. Now we have a min and a max. Are these relatives or absolutes? Okay. Here's our absolute maximum. What about this guy? So relative, relative, right? See it? Absolute would mean there would be nothing else above it or below it. But if this was an absolute maximum, this guy's higher, isn't it? If this was an absolute minimum, this guy's lower, right? So these are relative. Relative min, relative max. Let me label this A, B. So again, in your calculator, you're going to do your relative max and min the same way you always do. Second calc, and you're going to find it. So for lack of time, I'm going to give them to you here. Okay? You can do your increasing, decreasing off of this. So increasing, decreasing. At left to right, read left to right. My y value is increasing when x goes from negative infinity to that x value. And what's that x value? It should be at the 0. My graph is just a little bit off here. So I'm increasing from negative infinity to 0. Okay? Then, what am I doing right here? Decreasing. From 0 to where? What x value? What x value stops me? 2. My y is decreasing to infinity, but it is increasing between 0 and 2. See it? Now, jump up to this section. I come down. What am I doing? Decreasing. I'm decreasing from 2 to where? What's this x value? 4. And then I'm increasing from 4 to infinity. Okay? See it? I'm concave up. Where do I concave up? From what x value? You're right here trapped in here. From 2 to infinity. You're trapped in there. And concave down from where? Negative infinity to where? 2. Okay? The rest of them will pretty much be the same. Let's work on your range. We did your domain last, and this guy it was probably easiest once we get all these max and mins, then to do your range. Your range is your y value. So watch what's going to happen. It's going to come like this. I'm reading like this. Here goes my y's. Whoops, my y stopped. What is that y value of a? My x value is 0. What is my y value? -2. So I'm going from negative infinity to -2. Then I jump up here and I restart right here. What is that y value? 6. Good. From 6 to infinity. If it helps you, put your points right on here. I think it's easier to see. When you're doing the range, what value should you look at? The x or the y? The y. When you're doing the domain, you look at the x's. Okay? So how did this work out for you? Okay? Pretty good. Now, your zeros, we forgot to do your zeros. Your zeros. Your x-intercepts. These are the zeros of the numerator. So you're going to take this, and we can't factor, so what are we going to use? Either complete the square, that's a nice complete the square one, or quadratic. Now, it's going to come out to be what kind of number when you get the answer to this? Not irrational, imaginary. Why is it imaginary? Not touching the x-axis. So if I want to complete the square, let me complete the square on this one. Plus something, plus 4 minus something. It's so much easier. X minus 1 squared. This is a 1, this is a 1. Plus 3. So let me just get to this one. Subtract 3. Do you see it? Once you get here, and you have to take the square root, you have to stop. You just say, no real x-intercepts. And you can stop right there. There are no real x-intercepts. Your y-intercept, you're going to have one. So you're going to plug an x in for 0. 0, 0, 4 over -2. And didn't we find that as a y-intercept? Okay, on your homework, guys, this is what I want you to do. Don't do number 2. Don't do number 2 or number 6. Do you only have up to 6? Yes, you don't have 7. Okay, right now just don't do number 2 and number 6. We'll do that tomorrow. Tonight you're concentrating on your slant asymptotes. Okay? So that means you only 4 of them to do. 3 tests